Hello, welcome to our second lesson. In our previous lesson, we looked at X and Y-intercepts, and we defined X-intercept as a point where the graph intersects the X-axis. We also defined Y-intercept as a point where the graph cuts the Y-axis. So we are going to use that concept of X and Y-intercept in graphing the straight lines. For example, you might be required to sketch the graph of the following linear relations showing the X and Y-intercepts. So what do you do in a situation like part A? The first thing you need to do is, start with one of the intercepts. In this case, we shall pick the X-intercept. Now, for the X-intercept, we set Y value to be 0 because that is a point where the graph cuts the X-axis. That means the Y coordinate is 0. Once we set the Y coordinate as 0, we now substitute in our linear relation in part A. That is, where there is Y, we substitute with a 0. And that leaves us with this solution. So that is, when the value of Y is 0, then our equation becomes 2x plus 3 multiplied by a 0 is equivalent to 6. Then we simplify further, and that leads us to 2x plus a 0 is equal to 6. So 2x is equal to 6, and therefore we have the value of x as 3. So there we shall have a point, one of the points. The point is written as x, comma, y. That is the coordinate. So the value of x, in our case, is 3. Then the value of y is 0, because we set y to be 0. So it means the value of y is 0. This is the point that we shall plot. So our first point, I'm calling it P1. So the point we shall plot will be 3, 0. Next, we move on to the second intercept. In this case, is the Y-intercept. We go back to our equation. Our equation is 2x plus 3y is equal to 6. But because it is the Y-intercept, we set the value of x to be 0. Because Y-intercept is a point where the graph cuts the Y-axis. And along the Y-axis, the x values are zeros. So once we set the x value to be 0, we substitute in our linear relation. Where there is x, we put there a 0. So this leads us to this. Where there is x, we replace with a 0 because we have set x to be a 0 along the y-axis. So 2 multiplied by 0 is a 0, plus 3y is equivalent to 6. That means that we are left with the 3y, which is equivalent to 6. We therefore divide both sides by 3 so that we remain with y. That implies that the value of y will be 6 over 3, which is equivalent to 2. We now go ahead and write down the point. When writing down the point, we start with the x coordinate, then followed by the y coordinate. In this case, our x coordinate is 0. The y coordinate is 2. That means our y-intercept is 0, 2. Once we have the 2 points, P1, which is our x-intercept, and P2, which is our y-intercept, we now proceed and draw that particular graph. Because to draw a straight line graph, you only require 2 points. 2 points are enough to give you a linear graph. Now, once we have our x-intercept and y-intercept, we proceed and draw the graph. But here, we only need a sketch of it. Is enough. So we represent the 2 points on a Cartesian plane. So the first point is 3, 0, which is the x-intercept. So that means where there is x, we identify on the x-axis the point where we have the 3. Put across as a sign of plotting. We also identify on the y-axis where the value of y is 2. You put the plot. So we have our first point, P1, that is the x-intercept, and our second point, P2, that is the y-intercept. Once we have plotted the 2 points, we now take a ruler and join the 2 points. We now take a ruler and join the 2 points. So as you can see, we have joined our 2 points, point P1 and point P2. So this point P1 represents the x-intercept, while point P2 represents the y-intercept. We need to go further and represent the equation of that particular graph. That means we define our graph by representing the equation, which is 2x plus 3y is equal to 6. So with so doing, we say we have now used the knowledge of intercepts to graph a straight line. Let us now move on to a second illustration which will assist us understand this concept of graphing straight line using intercepts. So we are going to build on another complex illustration. In this case 2, we are having the equation y is equal to 2x minus 6. So we are considering a case where we have a minus sign. How do you treat this case? What we do, we just repeat the same procedure the way we handled in case A. That is, we start with the x-intercept. As I mentioned earlier, with x-intercept, we set the value of y to be 0. Once we set the value of y to be 0, we proceed and substitute in our linear relation. That means where there is y, we replace with 0. Then that is equal to 2x minus 6. At this point, we collect like terms. That means we collect minus 2, positive 2x to the left-hand side, so that we remain with the negative 6 on the right-hand side. So in this case, because 2x is a positive, we subtract 2x from both sides. That leaves us with negative 2x is equal to 0 minus 6. We therefore divide both sides by negative 2. Negative 2 cancels on the left-hand side. We are remaining with x. Then negative 6 divided by negative 2. The negative sign cancels. 6 divided by 2 gives us 3. That means the value of x is equal to 3 when the value of y is 0. Therefore, our point, still I'll call that point, let me now, for this case, I can call it point P3. So our point is 3, 0. So this is what we call the X-intercept. Let us now look at the Y-intercept. For the Y-intercept, we set the value of x as 0 and substitute in our linear relation. That means when x is 0, y is equal to 2 multiplied by 0, which gives us a 0, minus 6. So y will be 0 minus 6, and therefore that implies that the value of y is equivalent to minus 6. Therefore, what is our point? So our point, which in this case I'm calling it P4 to represent our point, will be, we start by writing the x coordinate, which is 0, followed by the y coordinate, which is negative 6. Now, we have our x-intercept as 3, 0. We also have our y-intercept as 0, negative 6. We need to draw the graph. So when drawing the graph, you need first of all to label the axis. The vertical axis, as we mentioned in our previous lesson, we called it y-axis. Then the horizontal axis is called the x-axis. The point where the two axes intersect is called the origin. In this case, we use 0. So we start by plotting the first point, which is 3, 0, where there is x. Identify the x along the x-axis, that is 3. Then the y-coordinate there is 0. So that means our point lies on the x-axis. And that's why it's called x-intercept, because the point lies on the x-axis. Our second point lies on the y-axis, is point 0, negative 6. Once we have plotted our 2 points, that is a point on the x-axis, what we are calling the x-intercept, and a point on the y-axis, what we are calling the y-intercept, you now take a ruler and join the 2 points. Once you join the 2 points, you obtain a straight line. We need to define our line by indicating the equation of the line. And in this case, we go back to the equation we are given, our linear relation, and incorporate on our graph. Our equation was y is equal to 2x minus 6. So using the 2 illustrations, we have been able to graph a straight line using intercepts. Look at this exercise. Let us look at this exercise. In the first question, for this equation, find the y-intercept by letting x is equal to 0. And in the second question, for this equation, find the x-intercept by letting y is equal to 0. And the equation is 2x minus y is equal to minus 4. In the first question, the equation is x plus y is equal to 4. So we can do that within some few minutes. Now, when we look at the first equation, x plus y is equal to 4, we want to find the y-intercept. Now, as I mentioned earlier, when you want to find the y-intercept, you set x to be 0. Once you set x to be 0, you go ahead and substitute in the linear relation where there is x with a 0. That means 0 plus y is equal to 4. It therefore means the value of y is 4. What is y-intercept? That means we go ahead and get the point itself in a coordinate form. When giving the point, we start with the x-coordinate followed by the y-coordinate. Since our x-coordinate is 0, then our y-coordinate is 4, which we have calculated. It therefore means that the y-intercept will be 0, 4. And we have solved that part 1a. Secondly, we want to find x-intercept for this particular linear relation. The relation reads 2x minus y is equal to negative 4. As I mentioned earlier, for x-intercept, you set the value of y as 0. Where there is y in our linear relation, you substitute with a 0. In this case, the relation becomes 2x minus 0 is equal to minus 4. That means 2x is equal to negative 4. What will be the value of x? To find the value of x, we divide both sides by 2. This implies that the value of x is equal to negative 2. Now, we go ahead and write down the point. When writing down the point, we start with the x-coordinate followed by the y-coordinate. So in this case, the point where the graph cuts the x-axis is negative 2, 0. And therefore, the x-intercept is negative 2, 0. Now, we want to consider a case whereby you only have one intercept and you are required to graph the straight line. What we do in this case, you are supposed first of all to look at what is given. In part A, you are required to sketch the graph of a line which is y is equal to 3. So we need to draw the Cartesian plane. So we just sketch the Cartesian plane. Look at our Cartesian plane. We have the y-axis and the x-axis. In part A, the equation is y is equal to 3. In this case, you identify the position y is equal to 3. Where is 3 along the y-axis? So the 3 along the y-axis is represented with a dot. That is the 3 along the y-axis. So, the line y is equal to 3 will simply be a line that will intersect the y-axis. And that line will be horizontal to the x-axis. So it's a line that is parallel to the x-axis, but passing through y is equal to 3. So you can say it's the y-intercept is 3, but that line is parallel to the x-axis, and therefore we draw a horizontal line passing through y is 3 and parallel to the x-axis. That will be our graph. So this is the line y is equal to 3. That means any point chosen at random along that line, its y value will be 3. However, the x values will be varying. Now, we are considering the line x is equal to negative 4. So this point can be identified along the x-axis. We identify the point x is negative 4 with a dot. That line will be parallel to the y-axis. The line is parallel to the y-axis. That means okay, it is x is equal to negative 4. That means all the x values along that vertical line is negative 4, while the y values along the line will be changing. The y values will be changing, but x values will not be changing. X values will remain to be negative 4 throughout, up to infinity, positive infinity, to negative infinity. So that is the line, and therefore this is what we call the vertical line. So all lines which are x is equal to, in form of x is equal to, they are passing through the x-intercept, and they are always vertical, and they are always parallel to the y-axis. We want now to confirm what happens when our line is passing through the origin. How do you sketch a line which passes through the origin? And you are given the equation of that particular line. We need to remember that when the line is passing through the origin, then its x-coordinate is 0, and also its y-coordinate is 0. So the first point will be 0, 0. We need to get a second point. To get the second point, we choose another value of x. In this case, we can let the x value to be 1. You choose any other value of x apart from 0. So you can choose the x value to be 1 or any other x value other than 0. When we choose the value of x to be 1, we find that the y value will be equivalent to 3 multiplied by 1, which is equal to 3. And therefore, the point will be the point of concern will be 1, 3. We therefore pick the first point, which is the origin, 0, 0. We pick the second point, which we have derived, 1, 3. We now go ahead and use the 2 points to sketch the linear graph. Once you have plotted your Cartesian plane, you now plot the points. The first point is 0, 0, which is origin. You mark using a big dot. The second point is 1, 3. That means the x-coordinate is 1, while the y-coordinate is 3. Once you have marked the 2 points using a dot or a cross, you now take a ruler and join the 2 points. Once you have drawn your graph, you represent the equation that you are given. In our case, the equation is y is equal to 3x. So using this particular illustration, you find that we have shown clearly how you can sketch a linear graph that is passing through the origin. So what is important is you need to know that the origin is the point 0, 0. That's the point where the axes intersect. You also need to choose another point other than 0. You choose another x value other than 0 and substitute in the linear relation to obtain the corresponding value of y. Once you have the 2 points, you go ahead and plot them and finally join the 2 points to form a graph. Now, in this particular exercise, in question 1, we are supposed to state the x-intercepts for the graph shown. Then, for question 2, we are supposed to state the y-intercept for this graph. Let us start with the first question. That is question 1. What is the x-intercept? For you to be able to state the x-intercept correctly, you need first of all to understand the definition of the term x-intercept. In our previous lesson, we did mention that x-intercept is a point where the graph cuts the x-axis. In this case, this graph, which is indicated, is cutting the x-axis at 2. And therefore, we can say that x-intercept will be the y-coordinate is 0, while the x-coordinate is 2. And therefore, what will be the point itself? The point will be 2, 0. And therefore, we can answer that question by saying that x-intercept is 2, 0. We have stated the x-intercept. So the graph is cutting the x-axis at 2. Let us now look at the second question, which says, state the y-intercept for the graph. So you need to study the graph very carefully. This graph is horizontal. It is a horizontal line. So using this particular graph, you will find that it is cutting the y-axis at point y is equal to -2. We therefore need to establish the x-coordinate at that point. And it is very clear that the x-coordinate at that point is 0. Why? Because along the y-axis, all the x-coordinates are 0. Therefore, we shall give our point, that's the y-intercept, as now a point. We can write it as follows. We now write it as 0, -2. That means we start by stating the x-coordinate, then followed by the y-coordinate. That is the intercept, 0, -2, now as a point. Sawa. So in this particular subtopic, we have looked at how we can use y-intercept and x-intercept to plot a graph. We have gone further and looked at how we can only use one intercept to plot a graph. That is a case where you have only been given x-intercept. How do you plot that graph? A case where you have only been given y-intercept. How do you plot that graph? And finally, we have looked at a case whereby the graph has been drawn and it is only cutting the x-axis at only one point. And in the second case, the graph has been drawn and it's only cutting the y-axis at only one point. And you have been given the equation of that graph. How do you get the point? We have done that, and I believe from these illustrations, you can be able to find the equation of a linear relation when you have been given both x-intercepts and y-intercepts successfully. Thank you.